Assalamualaikum and selamat sejahtera to my panels. My name is Nur Syafiqah binti Muhammad Hanif and I would like to explain my final year project entitled Synthesis and Characterization of Bidentate Schiff-based and diametal complexes. Schiff-base is known as the product of a chemical reaction between a primary amine and an aldehyde or ketone under certain conditions. Structurally, the oxygen in the carbonyl functional group of aldehydes and ketone is replaced by nitrogen to form the imine or azomethane functional group, which is characteristic of Schiff bases. These are the general formation of Schiff-base ligands, and R1, R2 and R3 refer to the alkyl group. For the problem statements, patients with inflammatory bowel disease called IBD may be due to genetic and environmental in IBD patients, such as excess oxidative molecules released during chronic inflammations, mitochondrial dysfunctions, or impaired antioxidant capacity of oxidative diets. It shows signs of increased oxidative damage. The preclinical and clinical studies have shown that a variety of endogenous and extrinsic antioxidant molecules are effective in reducing intestinal oxidation. Here is the significance of study. A bidentate Schiff-based ligands and their metal complexes such as zinc and nickel were synthesized and characterized. This study was done and increased the database information of Schiff-based and their metal complexes. This study also implemented conventional method with some modifications such as time to reflux and types of transition metal used. Tips in this study were to synthesize and characterize two bidentate Schiff-based ligands and their zinc and nickel complexes using elemental analysis, FTIR, NMR, UV-Vis, melting point, and magnetic susceptibility. For the scope and limitation, ligand 1 was synthesized using salicylaldehyde and benzylamine. Meanwhile, for the ligand 2 was synthesized using 2-hydroxyacetophenone and benzylamine. Two metal complexes, which zinc and nickel, were chosen in this study as a metal center. Schiff-based ligand and metal complexes were characterized using melting point, elemental analysis, FTIR, NMR, UV-Vis, and magnetic susceptibility. A representative Schiff-base was synthesized in an equimolar ratio of salicylaldehyde to benzylamine. Salicylaldehyde was mixed with benzylamine solution into a 10 ml of ethanol. The mixture was refluxed for 3 hours and cooled it down at the room temperature. The solid was filtered, washed, and dried under vacuum for overnight. Steps 1 to 3 were repeated using 2-hydroxyacetophenone. For the metal complexes, zinc 2-acetate was using 2:1 molar ratio and poured into 10 ml of ethanol. The mixture was refluxed for 6 hours and the complex is filtered out, washed with ethanol and dried in a room temperature under vacuum. The procedure was repeated using nickel 2-acetate. According to Purvey 2019, states that elemental analysis was used to calculate the percentage of carbon, hydrogen, and nitrogen elements for the synthesis complexes. Theoretical value of Schiff-based ligands were in a good agreement with the calculated value that are tabulated in a table below. However, ligand 1 could not be done for elemental analysis at melting point due to the formation simplify, which was in liquid form. For the melting point of ligand was lower than their metal complexes. Ligands possess melting point in the range of 120 degrees Celsius to 123 degrees Celsius. Meanwhile, for the metal complexes were above 200 degrees Celsius until decomposed. The yield percentage of ligands and their metal complexes are tabulated in table below. The yield percentage of ligand 1, zinc ligand 1 and nickel ligand 1 were recorded at 60.34%, 13.80% and 52.59% respectively. For ligand 2, zinc ligand 2 and nickel ligand 2 were recorded at 36.08%, 14.61% and 53.64% respectively. Azomethane group of ligand 1 and diametal complexes show strong bands exhibited in the range of 1608 to 1630 frequency due to the C double bond N. According to Sharma and Gondia 2018 stated that the metal complexes that were coordinated to Schiff-based ligand have lower absorption frequency of the C double bond N vibration mode. Meanwhile, the CO stretching frequencies were observed to have shifted from 1211 to 1218. For the ligand 2 and diameter complexes, azimuthine group were recorded at bands 1619 frequency. Meanwhile, for the CO bands were recorded from 1231 to 1232 frequency. Several new bands appeared in ligand 1 and diameter complexes at the range of 1454 to 1455 frequency due to the methyl group. Phenolic of ligand 1 appears at singlet peak at chemical shift of 7.48 ppm. This signal was shifted to downfield due to the deshielding of electronegative element such as oxygen and nitrogen. Aromatic proton was assigned to two different environments which labeled as A and B. The multiplied chemical shifts at range 6.89 to 6.91 indicates aromatic A, meanwhile aromatic B indicates 6.94 to 7.29 ppm. For the N double bond CH shows 8.72 ppm deshielded to the left due to the presence of nitrogen atom. Phenolic of ligand 2 appears at singlet peak at chemical shift of 7.49 ppm. According to Tadavi 2018 stated that hydrogen bond caused the shift moves to the higher frequency due to deshielding effect. The multiplied chemical shifts at range 7.27 to 7.3 indicates aromatic A, meanwhile aromatic B indicates 7.31 to 7.34 ppm. For N double bond CH shows 7.86 ppm deshielded to the left due to the presence of nitrogen atom. There was a presence of methyl group in L2 ligand 2 assigned at 3.16 ppm that shielded to the right. For carbon 13, phenolic of ligand 1 appears at chemical shift of 132.22 to 132.92 ppm. The chemical shifts at range 116 and 93 to 119.16 indicates aromatic A, meanwhile aromatic B indicates 127.27 to 129.07 ppm. For the N double bond CH shows 139.1 ppm deshielded to the left due to the presence of nitrogen atom. Meanwhile, for the phenolic of ligand 2 appears at chemical shift of 138.56 ppm. The chemical shifts at range 116.88 to 120.58 indicates aromatic A, whereas for the aromatic B indicates 127.04 to 129.43 ppm. For the N double bond C shows 138.56 deshielded to the left due to the presence of nitrogen atom. For the UVVs of L1 and dimethyl complexes show the electronic transition of benzene group of pi to pi star in the range of 208.87 to 216.15 nanometer. The transitions were shifted to the right, also known as bathochromic, which maximum absorption transferred to a longer wavelength with less energy. For the pi n to pi star of azimuthine group indicates the range of 247.72 to 256.12 nanometer, whereas for the N to pi star of azimuthine group transitions portray bathochromic, the shifting to the right with lower to the higher wavelength starting from 284.06 to 312.32 nanometer. Furthermore, ligand 2 and diameter complexes, which was zinc ligand 2, show the electronic transition of benzene group of pi to pi star in the range of 215.29 to 215.90 nanometer. However, for nickel ligand 2 shows hypochromic peak because according to Prativi 2022 states that the wave of benzene shifted drastically to the right. This occurs due to the decrease in absorption in intensity. For the pi to pi star of azimuthine group indicates the range of 252.07 to 252.18 nanometer, whereas for the N to pi star of azimuthine group, transitions in the range of 315.37 to 317.94 nanometer. According to the Harinas 2013 states that magnetic susceptibility measurements provide fundamental information about the amounts of unpaired electrons and the geometry of complexes. For zinc ligand 1 and zinc ligand 2 complexes exhibit diamagnetic properties because according to the Danaraj 2022 states that the D10 configuration in which there are no unpaired electrons for zinc. Meanwhile, for nickel ligand 1 and nickel ligand 2 were calculated to be 1.90 Bor-Manhattan and 1.83 Bor-Manhattan respectively, which coincide with the theoretical range 2.90 Bor-Manhattan. For both zinc and nickel for ligand 1 and ligand 2 were assigned as tetrahedral. To be concluded, the objectives, which were to synthesize and characterize two bidentate Schiff-based ligand and diameter complexes, were achieved. In infrared spectra, the strong absorption bands around 1608 to 1630 wavelength that indicated the presence of C double bond and group. In H&MR spectra, the band of azimuthine group of L1 and L2 were recorded at 8.72 ppm and 7.86 ppm respectively. Meanwhile, in C&MR spectra, azimuthine group of both ligand 1 and ligand 2 were recorded at band 139.1 ppm and 138.56 ppm respectively. In electronic spectra of ligand 1, zinc ligand 1 and nickel ligand 1 bands of azimuthine group appeared at range 284.06 to 312.34 nanometer respectively and assigned as to N to pi star transitions. The magnetic moment shows geometry of zinc ligand 1, nickel ligand 1, zinc ligand 2 and nickel ligand 2 complexes were tetrahedral. For the first suggestion is to substitute an advanced screen microwave approach for the traditional condensation used for prepared ligands and metal complexes. By using less solvent, this technique will increase the yield of new compounds. Next, for the thermogravimetric analysis, TGA, the behavior of water molecules can be determined whether the water molecules are coordinated to ligands or water molecules act as counter ions. The Schiff-based ligands and diameter complexes should be tested for antioxidant applications. However, the application could not be done due to the limitation of time. Therefore, we can use microwave-assisted synthesis. These microwave-irradiated reactions are done under solvent-free or less solvent, which at the same time reduce pollution and time-consuming, low cost, and offer high yields.